Hi everyone, my name's Bethany and I'm the current chair of the Physics Society. I hope you're all really enjoying this weekend with the Society's Gala, and I hope that you've seen a lot of different societies and looking forward to my event. So for the next 10 minutes or so, I'm going to be giving you a bit of a taster session of what we've been doing this year in terms of online events. It's going to be a virtual stargazing night. And what I'll do, I'll talk you through what you can see at the moment in the night sky in the spring season, and give you a few stories and a good few facts about what you can see in the night sky. So what I'm going to be doing is sharing a software with you, and hope you all enjoy it, and we'll get started. So I'll just share my screen and you should be able to see my screen now. So I hope you're wondering, what is this software? So this is a software that we use in the physics department and the physics society called Stellarium. It's a free software, anyone can download it online, and we use it mostly in terms of public events and outreach events and society events to show students and the public different parts and constellations with the night sky. So this has already been set to Preston at this current time, and so this is what you can see right now in Preston. Obviously at the moment it's not a really clear night, so this is what you'd be seeing if it was a completely clear night. And we can spin it around and have a look to see what we can see right now. So obviously the problem a lot was in Preston is light pollution and our atmosphere. So with the atmosphere, it protects us, it's a really useful thing, really is vital for human life. However, it's terrible for astronomy because it blocks out a lot of the light given from stars. So we can't really see that much of what we could see if we were outside of Earth. So what, in terms of these purposes, to give you the best experience, I'm going to turn off the atmosphere with the magic of the software, and we can see this beautiful band of the Milky Way here, and it stretches across the night sky, and you can see all the different colours from the clouds and the different colours of stars, and you can really see, you can really get a better experience from looking at this. Now obviously a lot of this looks the same, and it can be really hard to distinguish different stars and constellations. Trust me, to me, quite a few of the times they all look the same. But what I tend to do and what helps is to imagine drawings and the stars connecting each other. So again, with the magic of my software, we can do this. And this makes it a lot easier to be able to see different constellations. So what I'm going to do, we'll start off and spin around here, and I'm going to pop our way all the way up here. So the first thing we're going to look at is probably one of the most popular ones, and one of the most popular constellations in the night sky. We're going to be looking at Ursa Major. Now I'd hope that some of you would recognise this little part here. Some people name it as either the plough, the panhandle, the Big Dipper. Lots of different names it's been given, but the astronomical term is Ursa Major, which is Great Bear, which means Great Bear. So as you can see, the plough actually stretches way far out than the panhandle. It moves, it's connected to all these stars here, and as you can see, it does kind of make a bear. It's not completely accurate, obviously, but back in ancient Greek times, this is how they would tell stories, and people and different cultures developed this throughout the years, and this was one of the main ones. And if I can pop this on, this might give you a bit of a better sort of imaging. You can see the tail, the legs, the head, and it actually does look a lot better when we pop this. So we've got Ursa Major here, and we've got its little brother, which is Ursa Minor, which means little bear. And as you can see, still got the tail, still got the body here. And this is for most of them. Well, pretty much all of them, really. So they all represent different drawings in the night sky. As you can see, we've got Leo, Bootes, Cancer, lots of different ones. But I'm just going to turn that off for now. We're going to go on to Ursa Major. So the great thing about Ursa Major is you can use this constellation to find other stars. And the next big one we can find is if you take the ends of this panhandle and stretch it all the way over here, and stretch it way over, you can pop it on and find the next biggest star, next brightest star, which is Polaris. And Polaris is what we know as the North Star. Just move it over here. So Polaris is the star that is closest to our north point, and what this does is as the Earth orbits around, the stars seem to rotate around this northern point, and this star is the closest to that northern point. So what I'll do, if I just speed this up, you can be able to see this a bit better. As the days go by and the seasons change, you can see that the constellations will move around this star. I'll just pop back onto now. And this northern star won't always be the North Star. Polaris won't always be its North Star. This is because our solar system is moving around our galaxy. So as the Earth orbits around the sun will orbit around the central part of the Milky Way. And because of this, in a few thousand years, our northern point will move, and it'll probably be closer to another star, and another star will become our North Star. And this isn't actually the central point of the North Star, at the North Point. So if we pop this on, you can see that it's just slightly off. And it's the closest one to this North Point, but this is what I mean when you say that it's going to move, because as this moves on, it will center towards another star, and they're not sure where it will move yet. Obviously it's a good few thousand years away, and they're unsure which way it'll move, but they know that it's not always, that astronomers, that they know that it's not always going to be the North Star. So another one that we can look at, so just to point us out as well. So all of these, so obviously our North Star is here, and as I was saying before, that the stars and the constellations seem to move around this North Point. This means that constellations will set and rise as the seasons change, and you can see different constellations throughout the year. Now, the next constellation that comes to my mind in terms of popularity is Orion, with Orion's belt. So Orion constellation is actually better seen in winter than summer. It's a lot higher up in the sky, so you can see it better. You can still see it in the summer, but only it's very, very close to the horizon, so it's very hard to see, even on a really clear night. So it is better to see in the winter. And because of this, yeah, a lot of constellations will set and rise. However, these few constellations around here will not. They won't set, they won't rise, they'll constantly stay in the sky. They will move around, but they do tend to be very central. And these are what we call circumpolar stars, because it stays close to the North Pole. And another one of these circumpolar constellations is this one. It's Cassiopeia. Now Cassiopeia is one of the ones that stay up. It's fairly easy to find. So in the summer months or the spring months, it's a W. As you can see here, it's quite clearly seen. And then in the winter months, it rotates and turns into an M. So this one also is a really great one to find. Another really great extragalactic object. So what we can do is, if you've got this big sort of deeper point, and that's actually not the one that you want to look at. You want to look at this smaller one. So the stars are a little bit dimmer on this side, but you can still see them. So what you can do is follow this line down, and then you'll find a little smudge that's kind of hard to see in sort of the, you know, when the sky isn't that clear. But in some, you know, good nights, you can see this little smudge here. And obviously, so it's fairly close down to the horizon, but you can still see it pretty well. You know, if you're at the Forest of Bowland or Moor Park on a clear night. And what I can do is, if we zoom in and maybe get rid of this tree, we can find our closest galactic neighbour. And this is the Andromeda Galaxy. It's about 2.5 million light years away. So this image that, well, when you look at it in the night sky, you're actually looking at how it was 2.5 million years ago, because it's that far away from us. It's a spiral galaxy, just like our own, which means that you've got this center point, and it creates these beautiful bands called spiral arms, and it rotates around a center black hole, which is what they sort of been suspecting for a while. The center of these spiral galaxies tend to be black holes. So you can see this on a clear night. Obviously not in this much detail, but yeah, it's our closest galactic neighbor. And yeah, it's on this software you can really see it in clear image, but you will just be able to see it with in the night sky is just a bit of a smudge. But if you get even a pair of binoculars, or like an amateur telescope, that you can really see it in a lot more detail and a lot more glory. Great. So the last thing I want to show you, or the one things I want to show you as well, is a couple of planets that we can see. So we'll turn the ground on. It's great. I can just turn the ground on and off. It's great. So at the moment you can see Mars, which is fairly low down. At the moment it's in the western part of the sky, and it actually is fairly close to Orion. Obviously, so Orion's belt will be all the way down here, so you wouldn't be able to see the 3 stars. However, you can still see Betelgeuse, which is a fairly bright star. It's a fairly red star. And the way I look at fine planets is that it's not a very technical term, but they don't twinkle. Planets don't tend to twinkle because it's not got that sort of range of light being reflected of it. It's got a fairly constant reflection from the sun. And we can sort of look at this, and obviously Mars is fairly red star, so it's pretty easy to find in the night sky. And Mars doesn't tend to come out that often. It normally tends to stay towards the sun in most times, so it's quite nice to see at the moment. Yeah, so if you look in the western part of the sky, you'll be able to see that. Just seeing if we can see any other planets. No, I think it's just Mars at the moment, but Mars is a really good one to find. But yeah, no, so what I'll do, I'll stop it there. And yeah, I hope you all enjoyed this small taster session. I really hope that I'll just turn the screen off. I really hope that it's given you a bit of an insight on what we do here at the Physics Society. If you ever wanted to get involved or become a member with us for next year, We're always at Freshers Fair. We're always you know, we've got social media. You can find us on Facebook, Twitter, Instagram, and we do loads of different events like this. In pre-COVID times, we would take students up to the observatory. So we have an observatory up here at Alston, and we'd tell you some stories about some of the older telescopes that we've got, and then show you some cool images that we have on our newer telescope. But yeah, thank you all for listening, and thank you all for coming. I hope you enjoyed the rest of the gala. And yeah, hopefully I'll see some of you soon back in September. See you later. Bye.